Hello students, welcome back to maths class. Today we will do some more differential equation problems, right? So actually on that day I stopped. Some more problems are there. Second derivative problems are there. What is meant by second derivative means after doing the first derivative, right, dy by dx, again if we do one more time the differentiation, then it is called second derivative. Okay, so here we will find second derivative. First we will do some more problems from the same exercise. After that we will do second derivative problems. Okay, so come to the first question. So if f of x is equal to this one and g of x is equal to this one, then f dash x is equal to g dash x. While solving this problem, we will prove f of x is equals to g of x. If two functions are equal, then their derivatives also equal. So we will use that concept. Here two functions are equal, we will prove. So with that their derivatives also equal, we will prove, right? So come on, take the first question. So what is that? Given that, so given that f of x is equal to sine inverse of root of x minus beta by alpha minus beta, and g of x is equal to tan inverse of root of x minus beta by alpha minus x. Okay, so then we have to prove that f dash x is g dash x. So that means these two derivatives will be equal. If I prove the functions are equal, definitely their derivatives will be equal. So you take let f of x is equal to y, right, is equal to sine inverse of root of x minus beta by alpha minus beta. Bring that sign to this side, then you will have sine y is equal to root of x minus beta by alpha minus beta. Okay, so squaring, what happens? Sine square y is equal to x minus beta by alpha minus beta. Okay, so now you take cos square y. Cos square y is equal to 1 minus sine square y is equal to 1 minus x minus beta by alpha minus beta. So you take alpha minus beta as LCM. So come on, it is alpha minus beta. So you take minus x, minus of minus plus beta. Okay, so plus beta minus beta cancel. So your cos square y is equal to alpha minus x by alpha minus beta. Now you take your cos y. So cos y is equal to root of alpha minus x by alpha minus beta. Okay, so now see our g of x is in terms of tan, no? So I will take tan y. So tan y is equal to sine y by cos y. Okay, so is equal to, what is your sine y? Sine y is this one, right? So root of x minus beta by alpha minus beta by cos y is root of alpha minus x by alpha minus beta. So actually you consider this as first equation. Now we are getting tan y value, right? So tan y is equal to, both are having same power, right? Root means to the power of 1 by 2, it is a power. If both the numerator and denominator are having same power, we can take that power combinedly, right? So we can write that as root of, come on, x minus beta by alpha minus beta by, come on, alpha minus x by alpha minus beta. Okay, so is equal to, we can take this as x minus beta by alpha minus beta. If we send this term, it will be reverses, right? Numerator becomes denominator, denominator becomes numerator by alpha minus x. Both will get cancel, right? So you will have your tan y is equal to root of x minus beta by alpha minus x. Okay, send tan that side, then what happens? Y is equal to, it is tan inverse of x minus beta by alpha minus x. Okay, you consider this as your second equation. So from 1 and 2, what happens? Your first equation is y is equal to, now also we got y is equal to, therefore from 1 and 2, what happens? The value, what is that? Value sine inverse of root of x minus beta by alpha minus beta is equal to tan inverse of root of x minus beta by alpha minus x. That means implies f of x is equal to g of x. Therefore, f dash x is equal to z dash x. If two terms are equal, then their derivatives are also equal. Okay, so very simple. First you take f of x is equal to this one, right? You consider that as y, right? And bring that sine inverse this side, sine y value we got it. It is under the square root. So taking the square on both sides, sine square y is equal to x minus beta by alpha minus beta. Then cos square y is equal to 1 minus sine square y. So 1 minus, this is the value. So you take alpha minus beta, right? So take the LCM, right? Alpha minus beta minus x minus of minus plus beta. Okay, so plus beta minus beta cancel. So alpha minus x by alpha minus beta. So cos y is equal to root of alpha minus x by alpha minus beta. So with that you find out tan y. Why? Our g of x is a tan inverse. Actually our aim is, if f of x is equals to g of x, then f dash x is equals to g dash x. Okay, so for that sake you take tan y. Tan y formula is sin y cos y. We got a sin y value as well as we got a cos y value you take. So in numerator and denominator both are having same power, we can take that power combinedly, right? So take the power combinedly. So and send that denominator value to upwards, it will be reverses, right? So then you got tan y is equal to this, then y is equal to tan inverse of this one. So y is equal to tan inverse of root of x minus beta by alpha minus x. Here from first equation y is equal to sin inverse of root of x minus beta by alpha minus beta. So from 1 and 2, right, what is that? Sin inverse root of x minus beta by, both are equal, both are y. So both are equal means this is nothing but your f of x, this is nothing but your g of x. So f of x is equals to g of x. Okay, so if the functions are equal, their derivatives also equal. Therefore f dash x is equal to g dash x. Hence proved. Okay, so we have to prove that one, isn't it? If that is then means then prove that. So hence proved. Okay, so now come to the second question. What is your second question? If y is equal to x to the power of x, find dy by dx. Okay, so if your y is equal to x to the power of x, so write down given that y is equal to x to the power of x. Okay, taking log on both sides. Okay, so taking log on both sides. Okay, so it is log y is equal to log of x to the power of x. There is one formula, log a to the power of m is m log a. So we can write x into log x. From where you got it? It is log a to the power of m is equal to m log a. There is a formula in logarithms. Actually, why we have to take log on both sides? Already in differentiation we discussed variable and power is also variable. Whenever we are having variable and its power also variable, then we have to take a log on both sides. Okay, so why we have to take log on both sides? So that log a to the power of m is equal to m into log a. So we can write x into log x so that we can differentiate it, isn't it? Question is, if y is equal to x to the power of x, find dy by dx. That is the question. Okay, so that's why x to the power of x means variable, power is again variable. Generally variable will have some power, but here variable again it is having power also variable. So we don't have any direct formula in differentiation. So in such cases we have to go for logarithmic differentiation, I said, isn't it? So that's why taking log on both sides, then log a to the power of m is equal to m into log a form. Okay, now differentiate, right? Differentiate with respect to x on both sides. Both sides you have to differentiate with respect to x. Then what happens? D by dx of log y is equal to d by dx of x into log x. Okay. So which form it is? It is u into v form, product form, right? And this one you know it very well. D by dx of log y means it is 1 by y into dy by dx is equal to, now this is d by dx of x into log x, u into v form, right? So keeping x as it is, right? So d by dx of log x, right? Next, keeping log x as it is, d by dx of x. Okay, so it is 1 by y dy by dx is equal to x into d by dx of log x is 1 by x plus log x into d by dx of x is 1. Okay, so it is nothing but x cancel, 1 plus log x. Okay, so 1 by y dy by dx. Okay, so dy by dx is equal to y into 1 plus log x. Okay, so dy by dx is equal to y. What is y? In the beginning question, y is equal to x to the power of x. So it is x to the power of x 1 plus log x. Okay, that is the answer. Okay, so here we did two problems from the differentiation. So in the first problem, f of x is given to us, g of x is given to us. What is f of x? Any equation in terms of x, any equation in terms of function in terms of x, g of x are given and show that their derivatives are equal. So, here in this problem we did f of x is equals to g of x. We proved that f of x is equals to g of x. If two functions are equal, their derivatives also equal, right. So, that is why I have taken f of x is equal to y. You consider that as first equation, sine inverse of root of x minus beta by alpha minus beta. Then you take sine inverse this side, sine y is equal to this one. Okay, so sine square y, here square root is there, right. So, that is why you take a square. Okay, so sine square y is equal to x minus beta by alpha minus beta. Okay, so then you find out cos square y. Cos square y is equal to 1 minus sine square y. So, 1 minus sine square y, we got this value. So, alpha minus beta. So, alpha minus beta minus x minus of minus plus beta. Minus beta plus beta cancel, you got cos square y. So, we want cos y, taking square root on both sides. This side square will get cancel, cos y is equal to root of alpha minus x by alpha minus beta. Okay. So, then find out tan y. Tan y is equal to sin y by cos y. If you observe, numerator and denominator both are having same power, so we can take combinedly. Okay. After that, that term will get cancelled. You got your tan y. With that you try to get your y value. Just send a tan that side, it becomes tan inverse, right. So, y is equal to tan inverse of root of x minus beta by alpha minus x. That is your second equation. So, from 1 and 2, right, from 1 and 2, your sine inverse of root of this is equal to this one. That means from 1 y is equal to sine inverse, from 2 y is equal to tan inverse. Okay. So, sine inverse of this is equal to tan inverse of this one. So, your f of x is equals to g of x. If two functions are equal, definitely their derivatives are equal. So, hence proved. Come to the second question. Problem is given as y is equal to x to the power of x and find dy by dx. That means find the derivative of x to the power of x. Variable power, again it is in terms of variable. So, when power variable is there, again power is variable, then we have to go for logarithmic method, taking log on both sides, so that log a to the power of m is equal to m into log a. So, it is x into log x, u into v form, right. So, you take d by dx of x, right, u into, right. Product form means once we keep one value as it is, we will differentiate second value, plus we will keep second value as it is, we will differentiate first value. That is your product form. Formula d by dx of u into v form. We applied and we got dy by dx is equal to y into 1 plus log x, where y is x to the power of x. So, dy by dx is equal to x to the power of x into 1 plus log x is the answer. Okay. So, be perfect with these two problems. So, in this first problem, our aim is to know, right, to get the both given functions are equal. F of x, if two functions are equal, if f of x is equals to g of x, then f dash x is equals to g dash x. Okay. So, hence proved. In the second problem, variable power is again variable. Whenever power is having, right, power as a variable, we have to go for logarithmic method. We have to take log on both sides, then we have to solve our problem. Okay. So, practice these two problems perfectly. That is all for today. Have a nice day.